Okay, imagine this. Your old t-shirts, right? Instead of landfill, they get sorted perfectly for recycling, like 100% accuracy by a machine.
Wow.
Or picture wearing some fabric, just normal fabric, that spots a health issue in like 192 milliseconds. That's faster than a blink.
That's incredible speed.
It really is. So let's dive into this because machine learning, AI, it's not just in our phones anymore. It's literally being woven into fabrics.
Yeah, and what's really striking here is how these two, quite complex areas are coming together. You've got the deep science of textiles, especially these engineered ones we call polymeric technical textiles.
Right.
And then you have machine learning, which is just moving so fast.
Exactly. And we're not talking about, your average pair of jeans here. Polymeric technical textiles, these are fabrics engineered for really specific jobs. Think healthcare, like implants that the body accepts.
Biocompatible, yeah.
Or aerospace,
Yeah.
Super strong but light materials, even construction. And for this deep dive, we're looking at a really interesting review. It's from the journal Polymers, just out April 2025. It's called Machine Learning in Polymeric Technical Textiles.
And it's a great source because it pulls together a whole lot of research.
Yeah.
It shows how machine learning is, well, really shaking things up, helping design better materials, predict how they'll perform much more accurately, and even creating textiles that are, smart, responsive titty.
So if you're anything like us, you find this stuff fascinating, but maybe don't have hours to wade through dense papers, well, you're in the right place. We're going to unpack the key stuff, find those surprising aha moments, and give you a good handle on this field without getting lost in the technical weeds.
Okay, so let's start with the basics. These polymeric technical textiles, what exactly are they? Laying the groundwork.
Think of them as fabrics built for a purpose. Performance is everything. It's not like your comfy sweater where, feel and looks are key.
Right.
With technical textiles, it's about meeting tough criteria. Like a medical bandage fabric needs to be sterile, obviously. A firefighter suit, flame resistant, that kind of thing.
And the polymeric part just means they're made from polymers. These big molecules are fantastic because they offer such a massive range of properties. You can get flexibility, amazing strength, and you can even engineer them for specific functions like resisting fire, managing moisture, or, as you said, being biocompatible for medical use.
Right. And making these traditionally, it's always been this blend of knowing your materials, the science bit, and knowing how to turn them into fabrics, the textile engineering. It's a real balancing act to get those performance specs just right for whatever industry needs it.
So where does AI come in? How is it changing this established process? What's the big deal about adding machine learning to polymer research?
Well, the review really points to a few key areas where it's making a difference. Material design is becoming way more efficient. AI can sift through huge amounts of data to find the best material combinations. Performance prediction is getting better too. We can anticipate how materials will actually behave in the real world under stress much more reliably. And maybe crucially, it's helping make the whole industry a bit more sustainable.
And I suppose the materials themselves are just getting more complex. The demands are higher.
Exactly. That's a huge driver. If you need something that can handle intense heat, last forever, but still bend easily, the number of variables is just enormous. Machine learning gives us the tools to actually manage that complexity.
It makes sense.
Yeah.
Before we get specifically into textiles, the review mentions ML is already doing quite a bit in polymer science more broadly, sort of setting the stage, maybe.
Yeah, precisely. It gives context. We're seeing ML successfully predict really fundamental polymer properties. Things like tensile strength, how much pull it can take before snapping.
Okay.
How stable it is at high temperatures, even its glass transition temperature, that point where a polymer changes behavior with heat.
And they gave an example, didn't they? Something about Gaussian process regression.
Yeah, that was a good one. It's a statistical method, GPR, and it's predicting the tensile strength of these nanocomposite polymers with tiny bits added for strength really accurately. The errors are tiny, like 5 megapascals. It's like super precise, helps design much more reliable materials.
And it's not just predicting basic properties, right? It's also modeling more complex stuff, like how fabrics take dye.
Right, how polymers absorb dyes, how well the color sticks, color fastness they call it, and even how changing the surface of a material affects it.
And that ant colony optimization thing, that sounds intriguing.
It really is. It's inspired by how ants find food paths, basically. And it's being used to figure out the perfect dye recipes for blended fabrics, so you get a really consistent color, even with different fibers mixed together. The AI is kind of mimicking nature to solve that color variation problem.
Fascinating. And beyond the material itself, ML is also optimizing how things are actually made,
Yeah.
like spinning and weaving.
Yeah, exactly. Tuning all those parameters in manufacturing to control things like pore size in the fabric, the texture, how breathable it is. Very fine control.
And they mentioned neural networks for that.
Artificial neural networks, ANNs, sort of modeled on the brain, predicting mechanical properties like breaking strength or how much it stretches based on the settings used during melt spinning, which is a common way to make fibers, and the error rates. Super low.
Another big area seems to be understanding how biodegradable polymers break down, things like PLA and PHP plastics. That's vital for sustainability.
Absolutely. The review highlights a specific model, a random forest regressor, that's accurately predicting how composite materials age naturally just by looking at accelerated aging data.
So speeding up the testing process massively.
Hugely. It even did better than other models, and they compared 3 years of natural aging to just 1,000 hours of accelerated aging, and the strength loss was remarkably similar. Gives you much more confidence in predicting long-term behavior without waiting years.
Okay, so all this groundwork in polymers really sets the scene for what's happening now with smart polymer textiles. When we say smart textiles, what are we actually talking about?
This is where it gets really cool, I think. Smart textiles basically embed things like conductive polymers, even ML algorithms right into the fabric itself.
Wow.
The goal, wearables that can, monitor your health, sense the environment around you, maybe even adapt somehow.
Huge potential there. But the review mentions challenges, right? Especially with finding sustainable alternatives to metal conductors.
Yeah, that's a big one. You need conductivity, but it also needs to be flexible, washable, good for the planet. It's a tough list.
Which leads into that case study they included, using ML to design conductive e-textiles.
Exactly. Fully textile-based. They used Tencel yarn, that's a sustainable fabric base, and coated it with a conductive polymer called polypyrrole.
And the ML part helped optimize it.
Right. They used techniques called Bayesian optimization and Pareto front analysis. Fancy names. But basically, these ML methods helped find the best recipe, the best reaction conditions to get the electrical resistance of that yarn way down, make it really conductive.
And they found something interesting about an additive, didn't they?
Yeah, that ptylineosulfonic acid, which people often add to boost conductivity. Turns out, in this specific setup, it didn't really help much. ML helped figure that out.
So these optimized yarns, they actually wove them into fabrics.
They did, prototype fabrics. And they showed real promise for things like flexible wearable electronics or even fabrics that can generate heat. It's a big step towards truly integrated, comfy, smart clothes.
The review also mentioned something called VOS density analysis, analyzing keywords in research papers. What did that reveal about the field's focus?
It basically gives you a map of what researchers are concentrating on, and it shows a really strong focus on using ML and AI to, optimize material properties, make manufacturing more efficient, and improve quality control. All crucial stuff.
And does it highlight specific ML techniques being used?
Yeah, it does. Things like artificial neural networks, ANNs, convolutional neural networks, CNNs, those are great for image analysis, like spotting defects and ensemble learning, which combines multiple models for better accuracy. They're being used for prediction, defect detection, process optimization, across the board, really.
And it links to bigger trends, too, like IoT and Industry 4.0.
Definitely. Seeing keywords like Internet of Things and Industry 4.0 and even feature fusion, it suggests this move towards, digitized, automated textile production, aiming for efficiency and sustainability.
And designing new materials from scratch with AI.
That's another exciting part. Using AI to help design totally new polymers with better durability, more flexibility, better resistance to tough environments. That includes biodegradable ones and high-performance polymers for extreme uses.
So the keywords really point towards smart textiles. Defect detection, AI helping create materials, a smarter, more efficient future for fabrics.
Exactly. It paints a clear picture.
Okay, let's make this even more concrete. The review had that diagram showing specific ML applications in the textile industry now. What were some key examples?
Right, first one, textile waste sorting. Huge for sustainability. They're using tech like near-infrared spectroscopy, NIR, basically shining light on fabrics to see what they're made of.
Okay.
And combining that with CNNs, those image analysis neural networks, the result. Automated sorting of different fibers. And the accuracy is amazing, up to 100% for pure fibers.
Which is critical if you actually want to recycle effectively. Yeah. That circular economy idea.
Absolutely. Then there's predicting fabric defects. Imagine knowing before a thread breaks during weaving.
That would save a lot of time and material.
Totally. ML models are being used for that. They use regression tasks to predict things like weft breaks, warp breaks horizontal, and vertical thread breaks, even yarn bursts. And these automated ML tools are making it easier for companies to use these techniques. One study got an R-squared of 0.73 predicting weft breaks. It's pretty good predictive power.
So better quality control, less waste. What about developing totally new materials?
ML is helping there too, modeling complex 3D textile structures digitally, optimizing composites. They're using deep learning CNNs again, and also recurrent neural networks, which handle sequences well to simulate these 3D structures and predict properties like stiffness. And they're getting predictions within like 10% error.
That's impressive accuracy for simulation. And physiological monitoring. Wearables.
Yeah, this is fascinating. Embedding sensors in fabrics to track things like breathing. The review mentions a specific composite membrane, polyacrylonitrile, carbon nanotubes, latex.
Okay, quite a mix.
Yeah, it converts breath into electrical signals. Then ML algorithms analyze that signal in real time. They can potentially spot anomalies linked to conditions like diabetes, wheezing, sleep apnea.
Wow. And the response time was fast.
Incredibly fast, 192 milliseconds. Real-time insights.
And the last point on that diagram was about biodegradability, understanding how things break down.
Right. Especially for polymers like PLA and PHB. Using ANNs to model how things like seawater conditions affect how quickly they degrade. Understanding those mechanisms, hydrolysis, microbes, light, heat, and the factors influencing them, like temperature or humidity, is key for designing truly eco-friendly textiles.
It helps to understand a little about how these fibers are made in the first place, doesn't it? The review touched on production methods.
Yeah, just briefly to give context, like fiberglass, molten glass, squeezed through tiny holes. Pretty direct.
Compared to carbon fiber from PAN, which is much more involved, lots of heating steps, oxidation, carbonization, carefully controlled atmospheres.
Exactly. Much more complex to get those high-strength carbon fibers.
And the point is that the way you make the fiber melt spinning, electrospinning, wet spinning, hugely impacts the final material, right?
Absolutely. Melt spinning might give you strong fibers. Electrospinning, tiny nanofibers with huge surface area, great for filters. Wet spinning gives you more control for specialized stuff. So the production choice really depends on what you need the final fabric to do.
Makes sense. Now, no field advances without bumps in the road. The review was balanced. It pointed out limitations, too.
Oh, yeah, definitely. A big one is data. Machine learning needs good data, lots of it. If your data sets are small or don't really reflect the real world, the models might not work so well in practice.
And the cost. The computing power needed for deep learning.
That's another factor. Training these complex models takes serious processing power, specialized hardware. Not everyone has easy access to that.
And the wearable sensors themselves.
Yeah.
Reliability issues.
Right. In real-world use, things get messy. Sensor noise, variations between people. Making sure those wearable sensors are consistently accurate is still a challenge.
And finding materials for smart textiles that are truly sustainable and scalable. Still working on that.
Exactly. Lots of progress, but still hurdles to overcome.
But the review also looked ahead, right? Future directions. Where's the research heading?
Yeah, lots of exciting potential. Improving data collection is key. More IoT sensors mean more data, but it needs to be good quality, standardized data so the ML models can really shine.
And combining different AI approaches. Hybrid models.
That's another big one. Mixing data-driven ML with our existing knowledge of physics and material science, that could lead to much more accurate predictions, better optimization.
And doubling down on sustainability using AI.
Definitely. Using AI to cut waste in production, make recycling work better, improve those biodegradability models we talked about.
More automation in factories, too. Real-time control.
Yep. AI for predictive maintenance, knowing when a machine needs fixing before it breaks. Better quality control. Using robots more effectively for handling fabrics.
And just pushing forward with the wearables for health, for environmental monitoring, using AI to make sense of all that sensor data.
Absolutely. And the review also stressed needing standard protocols, more collaboration between different fields, materials, scientists, engineers, computer scientists, doctors. Getting everyone talking is crucial.
So painting a picture of that future.
Yeah.
What are some concrete examples of what we might see?
Well, imagine AI predicting a new material's properties while it's still being designed. speeding up innovation massively.
Or AI constantly watching production lines in real time, tweaking things to cut waste instantly.
Yeah. And AI optimizing how we use resources, water, energy, materials across the whole supply chain. Big environmental impact potential there.
Predictive maintenance becoming standard, so factories run much more smoothly. Fewer breakdowns.
And AI guiding robots doing really precise work, handling delicate fabrics, cutting complex patterns, stitching perfectly, higher quality, faster production.
And the health applications.
Yeah.
Maybe wearables with sophisticated AI that can genuinely give early warnings for things like heart problems.
Exactly. The review mentions systems integrating multiple sensors with AI showing high diagnostic accuracy. That could be life-saving down the line.
So if we try and boil it all down,
Yeah.
What's the main takeaway for you from this deep dive?
For me, it's that ML isn't just theory in textiles anymore. It's becoming a practical, powerful tool. It's set to really change how we design, make, and use these advanced polymeric technical textiles.
Yeah, I agree. It's driving innovation, efficiency, sustainability, pushing things forward in so many industries. It's really about making the fabrics around us smarter, more capable.
It really gets you thinking, doesn't it? You start wondering about, I don't know, self-healing fabrics designed by AI or maybe a completely circular textile system run by intelligent sorting. The possibilities seem huge.
Absolutely. And look, we've really just scratched the surface here. If this has sparked your interest and you want to get into the nitty-gritty of specific applications or the tech, that review we base this on, Machine Learning in Polymeric Technical Textiles and Polymers, is a fantastic place to start digging deeper yourself.
It really is an exciting time. Seeing materials, science, and AI come together like this feels like we're just at the beginning of seeing what's truly possible.